Hello everybody. In this video I'll be talking about maps and scale drawings. In class we actually did a scale model of somebody's room and we used the scale of 1 foot is going to be equal to 1 unit of on the square of the graph paper. A couple things we need to talk about here is that a scale drawing is an enlarged or reduced drawing of an object that is similar to the actual object. Remember, if it's similar, all the angles are the same, only the lengths of the measurements would be different. A scale is the ratio that compares a length in a drawing or a model to the corresponding length in the actual object. Also, it's important to note, if we look down here, at this scale, 1 centimeter equals 2.5 meters. Obviously, 1 centimeter does not equal 2.5 meters. What it's doing is it's setting up a ratio. And so the ratio in this case is we can make an actual over drawing ratio. We could make a drawing over actual as well, but I'll just choose one of them. And so what it's doing when it says 1 centimeter equals 2.5 meters, and you'll see this on a map, on a blueprint, any type of scale drawing that you might see. The actual it's saying is 2.5 meters, and the drawing it's saying is 1 centimeter. And so it's just setting up a ratio here. So if the side of the house is 3 centimeters, we're talking about this house now, so in the drawing, so we could put that on the bottom. Remember in class today we talked about making sure you label your ratio so that you know which numbers go on top and which numbers go on bottom. So if the side of the house is 3 centimeters in the drawing, so 3 goes on the bottom, what is the actual? So we need to know what the actual is. So x. And then just like the last few lessons we've done, we can solve this using cross products. So we can say 2.5 times 3 is going to equal x times 1. And so in this case the actual is going to be 7.5 meters. And so we can just answer like that, 7.5 meters. You wouldn't actually answer with the variable. You just answer with the number and the units that correspond to the number. Let's try another one. Let's say there's this train car here, and you have a model, little toy train car, and it's 7 inches long. And you know that the actual train car would be 609 inches long. You can use both of these pieces of information to figure out what the scale of the train is. So you can make up actual over model. excuse me, or model over actual. Like I said before, it doesn't matter which one you do. You just pick one. I think I did actual on top first last time, so I'll do the model one this time. So if we know that the model is 7 inches and that the actual is 609 inches, we can figure out, and this isn't a solve for x situation, this is we're just going to figure out the scale, and we do that just by reducing. So do we know that both these numbers are divisible by 7? No, we don't really. 609, not really sure if that's divisible by 7, so we're going to check it out. 7 goes into 60, what is that, 8 times 56, 49, okay, so 87. So if we divide these both by 7, we will get 1 over 87. So the scale of this model, and notice the inches are the same in this ratio, and when that's the case, we can leave them off. So the scale is 1 over 87. And that should be enough for this video. Thanks for watching.